that before watching this video, watch my previous tutorial in which I have shown how to find the determinant of the matrices which has the large number of rows and the large number of columns. So here we have our first example, and we are going to find the determinant by making the use of the shortcut technique, in which that technique I have described in the tutorial number 1. So in this case, in order to find the determinant of this, what we need to do is we need to make all the columns in this row as 0 except this one. So what we are gonna do is, this is our first row, second row, third row, fourth row, fifth row and sixth row. So what we are gonna do is we are gonna make this element 0. So in order to make this, we need to do a row operation, that is R6 should be in such a way that R6 minus 2 times R1. So here we'll get 1 0 0 0 0 2, and this will be 0 1 0 0 2 0 0 0 1 2 0 0 0 0 2 1 0 0, and this will be 0 2 0 0 1 0. This will be 0 0 0 0 0, and this will be 1 minus 2 times 2 is 1 minus 4, that is -3. And now what we are going to do is, here we can either make the use of 1, that is this element, into cofactors of 1, and we are going to take here plus sign because this is first row and first element, and when we sum this two we get an even number. So when we get an even number, we need to multiply this element with plus sign, and we get an odd number, then we need to multiply this element with negative sign. So here we have an even number, so we can take plus 1 times the cofactor of 1, and the cofactors of 1 are these all elements. But we can find this value by taking another choice, that is, or we can take -3, this element, times the cofactors of -3, and this is first row, second row, third row, fourth row, fifth row, sixth row, and this is first element, second, third, fourth, fifth, sixth. This is our sixth row and sixth element, and the sum is even, so we are going to multiply this element with positive sign, and positive multiplied by negative is again negative, so it does not make any effect. So what we are going to do is we'll make the use of this way, and we are going to find the value of the determinant. So -3, this will be -3 into the cofactors of -3 will be these all elements. So this will be 1 0 0 0 0, and here we have 0 1 0 0 2, and here we have 0 0 1 2 0. Here we get 0 0 2 1 0. Here we'll get 0 2 0 0 1. And now what we are gonna do is, again we can take -3 times this element times 1 times cofactor of this element, that is 1, and as this is first row and first element, so the sum is again even, so we are going to multiply this element by positive sign. So positive multiplied by positive is again positive, so it does not make any effect. So -3 times 1 times the cofactor of this element will be 1 0 0 2. This will be 0 1 2 0. This will be 0 2 1 0, and here we have 2 0 0 1. And now what we are gonna do is we should make this element 0, so we need to perform the row operation. So this is R1 R2 R3 R4, So R4 must be in such a way that R4 minus 2 times R1. So here we have negative 3 times 1 times, this will be 1 0 0 2. Here we'll get 0 1 2 0. Here we have 0 2 1 0, and here we'll get 0 0 0, and this will be 1 minus 2 times 2, that is negative 3. And again, what we are gonna do is we can take either this element or this element and find its cofactors. So negative 3 times 1 times, will take negative 3, and this is first row, second row, third row, fourth row, and this is first element, second element, third element, fourth element. So we get 4 plus 4, that is equal to 8, which is again an even number, and we are gonna multiply this negative 3 with positive. So positive multiplied by negative is again negative, so it does not make any effect, times the cofactors of negative 3. So here we get negative 3 times 1 times negative 3 times the cofactors of negative 3 will be 1 0 0 0 1 2, and this is 0 2 1. And again we have this element as 0, so we can directly take this element and multiply it by the cofactors of this element. So negative 3 times 1 times negative 3 multiplied by this element 1, and this is in the first row and first element, so the sum is again even. So positive multiplied by positive is again positive, so this will be cofactors of 1, that is this element. So negative 3 times 1 times negative 3 times 1 times the cofactor of this element are 1 times 1 minus 2 times 2 is 4, so this will be negative 3 times 1 times negative 3 times 1 times, this will be negative 3, and our answer is 3 times 3 is 9, 9 3s are 27, and here we have a negative. So negative 27 is the answer for this determinant. And now we are going to focus on some properties on the determinants. So now we are going to discuss some properties which are based on the determinants. So in this case we know that determinant of AB is equal to determinant of A times the determinant of B, and we know that determinant of matrix A is equal to determinant of matrix transpose, and we know that if determinant of K times A can be written as K to the power n times the determinant of A, where n is equal to order of A. And another property what do we have is when all the elements in determinant, all the elements in row or column in determinant are 0, then the value of determinant is also equal to 0. Let's take an example. So here we have 0 0 0 1 2 3 4 3 5. So here all the elements in the first column are 0, and let's find the value of this determinant. So here we have 0 times, this is 5 3s are 15 minus 4 2s are 12, negative 1 times 0 plus 2 times, this will also be 0, and the value of this determinant is 0. Means when all the elements in the row or column in the determinant are 0, then the value of the determinant is also equals to 0. And another property we have, when all the elements in row or column are identical in two rows or two columns are identical, then the value of determinant is also equal to 0. Let's verify this. So if you have 1 1 1 1 1 1 2 3 6, then the value of the determinant must be equal to 0. Let's check out this. So 1 inside the bracket, 6 minus 3 minus 1 inside the bracket, 6 minus 2 plus 1 inside the bracket, 3 minus 2, and we are going to find the value of this determinant. So this will be 3 negative 1, this will be 4 plus 1, this will be 1. So here we have 3 minus 4 plus 1, that is equal to 0. And in the another case, we have a very special property, that is if the determinant is in the form of k x1 x2 x3 k y1 y2 y3 or k z1 z2 z3, then we can write this determinant as k x1 x2 x3 y1 y2 y3 and z1 z2 z3. And or if we have this determinant in this form kx1 kx2 kx3 ky1, this will be y1 y2 y3 z1 z2 z3, then we can write this determinant as k x1 x2 x3 y1 y2 y3 z1 z2 z3. So these were some basic and important properties of the determinants, and depending upon this we are going to solve some examples. So here's our question. If A and B are 3 by 3 matrices such that the determinant of A is equal to 3 and the determinant of B is equal to 2, then we need to find the determinant of 3 times AB. So we know that this determinant of 3 times AB can be written as 3 to the power n times AB. Since we know that determinant of k times A can be written as k to the power n times the determinant of A, where n is the order of this A. And when we multiply this 3 by 3 matrices, if A is the matrix with 3 by 3, 3 rows and 3 columns, and B is another matrix with 3 rows and 3 columns, and when we multiply this, our result must be 3 by 3, that is the rows of A and column of B. So here we should take 3 to the power 3, as the order of this resultant is 3, times the determinant of AB, and this can be written as 3 to the power 3 times determinant of A times the determinant of B. Since we know that determinant AB can be written as determinant of A times the determinant of B, so 3 to the power 3, determinant of A is 3 times the determinant of B is 2, so this will be 27 times 3, this will be 7 3s are 21, 2 are 6 7 8, multiplied by 2, so 2 1s are 2, 8 2s are 16, so 162 is the value of determinant of 3 times AB. So let's solve another example. So here we need to find the determinant of this matrix, and what we are going to do is, in the case, let C1 in such a way that C1 plus C2 plus C3, this is our column 1, and so as we applied this condition, the column operation, so 1 plus B plus B plus 1, and here we have B and 1, this will be B plus 1 plus B plus 1, this is 1 plus B as it is and 1, This is 1 plus 2b plus 1, and here we have 2b and 1. So we can write this as 2 plus 2b, 2 plus 2b, and 2 plus 2b. This will be b, 1 plus b, 2b, 1, 1, 1. This is determinant. And now we know that when the determinant of is the form k x1, x2, x3, k y1, y2, y3, k z1, z2, z3, then we can write this determinant as k inside the bracket x1, x2, x3, y1, y2, y3, and z1, z2, z3. So in very similar fashion we can write this determinant as 2 plus 2b, and here we have 1, b, 1, and here we have 1, 1 plus b, and 1, here we have 1, 2b, and 1. As these two columns are identical elements, then the value of this determinant must be equal to 0. So 2 plus 2b multiplied by 0. So here we get 0 is the final answer. Let us take another example. So here we have our next question. And in this case, now in very similar fashion, what we are going to do is let column 1 be in such a way that column 1 plus column 2 plus column 3. So this will be x plus a plus a. This will be a plus x plus a. This will be a plus x, and the remaining elements will be same. So this determinant we can write as x plus 2a. This can be written as x plus 2a. This can be written as x plus 2a, and the remaining elements are same. And now what we are gonna do is, as we know that k x1, x2, x3, k y1, y2, y3, k z1, z2, z3 can be written as k x1, x2, x3, y1, y2, y3, and z1, z2, z3. So in the very similar fashion we can modify this determinant as x plus 2a inside the bracket 1a, 1xa, and this is 1ax. And now what we are going to do is we need to make these two elements 0 in order to find the value of this determinant. So if we perform the row operation, that is let r2 in such a way that r2 minus r1, and r3 in such a way that r3 minus r1, then this determinant can be modified easily as x plus 2a times 1a. This will be 0, this will be x minus a, and this will be 0, and here we have 0, 0, and x minus a, and this can be written as x plus 2a times 1 into cofactor of 1. So x plus 2a multiplied by 1, and cofactors of 1 are x minus a bracket square. So our final answer is x plus 2a multiplied by x minus a bracket square. And here we have another example which is in the very similar fashion of the example that we have previously solved. So here what we are going to do is let c1 be in such a way that c1 plus c2 plus c3, and here we'll get x plus 3a, and this is a, and here we'll get x plus 3a, and here we have x a, and we get x plus 3a, here we have a, x a, and here we get x plus 3a, and here we have a, x. And we can take this x plus 3a outside the determinant and write the remaining determinant as 1a, this will be 1 x a a, and here we'll get 1 a x a, and here we have 1 a x. And now we need to make all these three elements 0 in order to find the determinant of this matrix. So I will write this here. So this can be written as x plus 3a multiplied by 1 a. This will be 0, x minus a, 0 and 0. When we perform the row operation, this will be 0, this will be 0, this will be x minus a, and here we have 0, this will be 0, 0, 0 and x minus a. So finally we get x plus 3a times 1 times the cofactors of 1. So we'll get x minus a 0, 0, 0, x minus a, 0, 0, 0, x minus a. And now what we are gonna do is we are gonna do x plus 3a times x minus a times the cofactors of x minus a are x minus a bracket square. So our final answer will be x plus 3a times x minus a bracket cube. So in this way we can find the determinant of any matrix which has 4 rows or 4 columns or 6 rows or 6 columns in short span of time. So let's solve this one. So here we have C1 should be in such a way that C1 plus C2 plus C3, and here we'll get 1 plus x plus 2 plus 3. Here we have 2, 3. This will be 1 plus 2 plus x plus 3. Here we have 2 plus x and 3. Here we have 1 plus 2 plus 3 plus x. Here we have 2 and 3 plus x. And now here 3, 4, 5, 6. So we have 6 plus x, 3, 4, 5, 6. Here we have 6 plus x. Here we'll also get 6 plus x. This will be 2, 3, 2 plus x and 3. We have 2 and 3 plus x, and we are gonna take 6 plus x outside. So 6 plus x, here we have 1, 2, 3, 1, 2 plus x and 3. Here we have 1, 2 and 3 plus x. And now we are gonna perform the row operation in such a way that R2 should be R2 minus R1, and R3 should be R3 minus R1. So this will get modified into 6 plus x. Sorry, this will be 6 plus x. Here we have 1, 2, 3, and this should be 0, and 2 plus x minus 2 is x, and 3 minus 2 is 0. This should be 0, 0, and this should be x. And now we can write this as 6 plus x multiplied by 1 and multiplied by the cofactors of 1. So this will be x square. So 6 plus x multiplied by x square is our final answer. And now in this case we are gonna do C1 should be in such a way that C1 plus C2 plus C3, C1, C2, C3 plus C4. Okay. So here we have, I can write this directly now, that is 4, 5, 6, 7, 8, 9 and 10. So this will be 10 plus x, 2, 3, 4. Here we will get 10 plus x, 2 plus x, 3 and 4. Here we'll get 10 plus x, 2 and 3 plus x. Here we'll get 4, and here we'll get 10 plus x. This will be 2, 3 and 4 plus x. Now I can take 10 plus x outside the determinant and can write 1, 2, 3, 4. This will be 1, 2 plus x, 3 and 4. This will be 1, 2, 3 plus x and 4. This will be 1, 2, 3 and 4 plus x. And now if we do the row operation, that is R2 should be in such a way that R2 minus R1, R3 in such a way that R3 minus R1, R4 in such a way that R4 minus R1, R1, R2, R3, R4. Okay, so then we can write this as 10 plus x. This is 1, 2, 3, 4. This will be 0. This will be x, 0, 0. This will be 0, 0, x, 0. This will be 0, 0, 0 and x. And now in order to find the value of this determinant, I will write it here. So this will be 10 plus x multiplied by this element 1 multiplied by the cofactors of 1. So I can write this as multiplied by x, 0, 0, 0, x, 0. This will be 0, 0, x. And again I can write this as 10 plus x times x, this element, and multiplied by the cofactors of this element are x square. So this will be multiplied by x square, and our final answer will be x cubed multiplied by 10 plus x. So let's take another example. Here we have a question, and here if A is the matrix Aij, that is a 3 by 3 matrix, and B is the matrix Bij, 3 by 3 matrix, such that Aij is equal to 2 to the power I plus j times Bij for all I and j, and if the determinant of B is equal to 2, then we need to find the determinant of A. So we can write this as A is equal to first row first element, first row second element, first row third element, second row first element, second row second element, second row third element. This is third row first element, third row second element, and third row third element. This is 3 by 3, and we need to replace this matrix by this condition. So this is A, and this is 2 to the power 1 plus 1 times B12. This will be 2 to the power 1 plus 2 times B12. This will be 2 to the power 1 plus 3 times B13. This will be 2 to the power 2 plus 1 times B21. This will be 2 to the power 2 plus 2 times B22. This will be 2 to the power 2 plus 3 times B23. And here we have 2 to the power 3 plus 1 times B31. Here we have 2 to the power 3 plus 2 times B32. And here we have 2 to the power 3 plus 3 times B33. And now what we are going to do is we can simplify this determinant. So this will be 2 square B12, 2 cube B12. This will be 2 to the power 4 B13. This B11, here we have first row first element, and here we'll get 2 to the power 3 B21, 2 to the power 4 B22, and here we have 2 to the power 5 B23. Here we have 2 to the power 4 B31. Here we have 2 to the power 5 B32, and here we'll get 2 to the power 6 B33. First or first element, first or second element, first or third element. Okay, everything is correct. And now we can, this is the crucial step here, and from this row I'm gonna take 2 to the power 2 outside. So 2 to the power 2 outside from this row. From this row I'll take 2 to the power 3 outside, and from this row I'll take 2 to the power 4 outside. So we can write this as B11, as I have taken 2 to the power 2 from this row. So here we'll get 2 times B12 and 2 to the power 2 times B13. And from this row I have taken 2 to the power 3 outside, so we can write this as B21, B22 times 2, and this will be 2 to the power 2 B23. And here we have b31, 2 times b32, and this is 2 to the power 2 times b33. And now we can take 2 outside from this column and 2 to the power 2 outside from this column. So this will be 2 square times 2 cube times 2 to the power 4 times this 2 and times 2 square, and we get b11, b12, b13, b21, b22, b23. This will be b31, b32 and b33, and this is a determinant b, and the value of the determinant b is 2. So this will be 3, 5, 6, 7, 8, 9, 10, 11, 12, 2 to the power 12 multiplied by the value of this determinant is 2. So our final answer is 2 to the power 13.